I think I am live. Hello, hello. Yeah, hopefully everyone's doing alright today. Apologies for showing up a little bit late. Um, yeah, I decided to eat a little bit more food, and unfortunately that means I have to show up a little bit late because, you know, time is not something I can magically create, unfortunately. Yeah, anyways. This is day 45 of studying compilers every day until I land a compiler role. I'm about to do the LeetCode daily, and then I'll explain the whole mem to reg situation and how I'm deciding to, I guess, implement fee insertion, which we were a little bit stuck on last stream. So yeah, I got some ideas. I'll explain them when the time comes, but for now, the LeetCode, I guess, always comes first. So let's get this started. Triangle. Okay. Okay, this looks very DP. Okay. Oh, that extra space? Wow. Surely there's a way. Topics, DP? Okay, yeah. Well, great. Ah, wonderful, wonderful. Okay, how do we reason about this? Okay. So, like, each row it grows a little bit, so we can kind of iterate backwards, even, I think. What's the discussion look like? More test cases. Yeah, okay, so, sure. Oh wait, this is interesting. Okay. Any hints at all anywhere? No. Okay, what do I even DP on here? I don't think I'm getting this. Or I'm just like groggy from having just eaten. I don't know. One of the two has to be true. Okay. I don't think we can do this greedily, at least. Yeah, I guess we could like continuously shrink the vector, so we can do TP is triangle.size. Can do that, and then we can reverse iterate through triangle. So for So we have triangle.rBegin. Rend. Is this how this works, I think? Okay. Oh, we need to default initialize this to like what's the C++ int or max int? Is it just int max? I feel like that exists somewhere. Int max. Okay, does this compile? Okay, yeah, perfect. So we want return dp00, I believe is what we want. Or we just want dp0, actually. Okay, so for each I in iter, I think. Is this how we would do this? Okay, it compiles, which is perfect. In designing compiling in C++, how do you balance between optimizing for compilation speed versus runtime performance? Interesting. Yeah, that's a really good question. I mean, that's kind of just like a trade-off you would want to make based on like, just based on like what your goals for it are. Like, I think that LLVM core generally, I think it tries to score a balance wherever possible. So like, performance comes first, but if it comes at the cost of like increasing the runtime substantially, then I would assume it would skip something like that. I think also sometimes runtime performance is sacrificed just for like simplicity. Like for instance, the mem to reg pass. I was looking at this last night because I was trying to figure out if there was a way to like, so like the algorithm in like all the papers for like SSA construction, which I'll explain later. That algorithm usually iterates like once. You basically like traverse the entire program once per variable that you want to process. I was looking if there was a way to do it just like such that you traverse over the program only once, but it turns out LLVM's implementation also traverses it once per variable. And I thought about like, I was like, this makes no sense. It feels so slow, but I assume there's just like a very substantial simplicity reason behind it at least. And then like the completely opposite approach to all of this, just like as a aside from like LLVM core, an aside is like Rust, which historically has very bad compile times. I'm not sure if you've like heard, but that's like one of the largest issues with the language from a lot of people that use it, and they've been like making steps towards making it better, but at least in the past their priority has been performance over compile time. So yeah, I don't think that really answered the question, but that's like kind of just like my bundle of thoughts on it, I guess, if that makes sense. Okay, so we want for each number, oh, we should overwrite right to left, I think. Right? We could do a cur, even. Yeah, this would just be, this would scale O of n. This is 2n, I guess. So we can do this. And then, oh, we would need, so we can do that, and then this should not be DP. This should be cur, I guess. So cur is, how do we like collapse this in a reasonable way? Oh, I'm giga overthinking this. We don't need a second array. Because at each one we can either access index I or I plus 1. And we're iterating bottom up through the triangle. So, oh, this is not the right image. Let me just like ignore the Valorant. Yeah, sorry about that. wrong thing I clicked, but yeah. So in this example we have this triangle drawing is misleading. the way that I'm thinking about it in terms of like vector space, we have 2, 3, 4, and then 6, 5, 7, and then 4, 1, 8, 3. So it's like a right triangle more than like this isosceles shape it tries to project onto us, I guess. Or not even isosceles, just like this shape. So we're iterating not top down because that's annoying to store, but we can iterate bottom up sort of. And the idea here is we get each of these and then, so the current state of cur, we start with just having the bottom row completely filled in. So let's array here. This for now we'll do like 4, 1, 8, and then 3. And then the idea here is at each of, let's just like add the next row on top. So like 6, 5, and 7. Each of these we can only read like this inner triangle. So at 6 we can only look at these two. At 5 we can only look at these two. And then at 7 we can only look at these two. So what that means is everything to the left of each of these, we don't care. Like everything to the left of it doesn't affect the current value. So what we can do is we can kind of just iterate through this in this direction actually. So then we can reset this to whatever the path that includes 6 is. So here we would pick the minimum of these two and then add that to 6, and we would overwrite this one tile here. So this would become 7 because it's 6 plus 1. And then you'll notice that we can do the same with 5 here, but these two solutions are still preserved because we've only overwritten the stuff to the left of it specifically. So with 5, we take the minimum of these two, that's 1. So then we can overwrite this with 6. And then these two, or I guess with 7, we take the minimum of these two, which is 3, we add 7 to that, and then that becomes 10. And then we don't care about the rest of this anymore. This can stay as like random garbage. Or like a random garbage value because we never look at it again. Because the next layer we throw onto here is the 3 and the 4. So let me do a little bit of erasure. Yeah, there we go. That's perfect. Okay. So then here we look at 3 and 4. Let's put this here, 3 and then 4. And then we iterate over these two. Let's just assume we're iterating over 4 right now. Minimum of these two is 6. So then we overwrite this again with 4 plus 6 is 10. And then you'll notice after we iterate through this 4, we never access this 3 again. So we can leave these garbage values behind. Yeah, that's like the fast explanation for how I'm thinking about this. Hopefully that made some degree of sense. What do I need to do? Oh, I should probably just copy triangle back. Triangle.back.begin. Triangle.back.end. We can do that, I think. Oh, this won't compile because of that. Let's try that again. Bro. Okay. Unlucky. Triangle, pop back. Let's see. Why doesn't this work? Oh. I know why that doesn't work. And then, okay. Cool. That's a good start. So now we can do that thing. So then dp at I equals we want iter yeah, we can do it like this. Iter at so that's the one. Iter I min of dpi and dpi I+1. Yeah, and then this should just solve, I think. What is wrong here? Iter the fuck? Okay, we're gonna do this differently. We're just gonna change this line with a while triangle size. So while it has things in it, we can iterate like this, and then we can change to that. Let's make it triangle.back. So we want triangle.back at I. And then we can triangle.popback. And this should work. Oh, what? What? Why is this breaking? Why is that the thing that breaks? Member name or what? Are we tripping? Was? What am I missing? Oh, I see what. Damn it. What is brother talking today? After this leak code, I will. Oh, not size. Yeah, after this leak code, I'm gonna hopefully properly implement mem to reg. I know I keep saying that, but I think I actually know what to do now. Yeah, okay, my solution's slow because I keep popping back. I'm gonna see if I can do it faster. C++ reverse, iterate, vector. What instructions exist in your IR? Currently it's just like, some of the basic binary ops. You can call their functions, and then hopefully by the end of today we just straight up have control, like branching control flow. It's pretty minimal right now. I plan on extending it out. In terms of like the C source code that it accepts right now, the interesting stuff it takes are like some binary operations, basic function calls, and then if statements right now. It also has proper scope handling, which is pretty neat. Oh, I have to subtract from the editor. I see. So for auto equals again, it's not triangle.rend back minus is the thing there. Oh, that's good, Seb. Good to see you. Yeah, leetcode has Vim binds actually. It's in settings and then code editor, and you can turn on Vim. It also has Emacs binds, which I think is really funny, but yeah. It's also relative line numbers somewhere here. Somewhere. Oh, yeah, here. Yeah, it's quite nice. I'm enjoying it. So we want back.size. Does this work? I think this pop back is inevitable. Love and hate them? Yeah, fair. Back dot at I? Is this why? Or like arrow? Oh, I hit the wrong button. Oh, fuck. Vector. I don't remember how to read from vectors apparently. At. Yeah, at. Why is this out of bounds? The fuck? Oh, I know why this is. Yeah. Begin minus, or I guess minus that first. You can do that. I think this should just do it in one pass. Why is this overflowing? Or not overflowing? Why is this failing? I feel like I'm just doing the reverse iterator wrong. R begin, R end. Why am I struggling with this? Wait, so do we plus it? Do we like minus it? Like, how do we do this? What's the correct direction? Is there like a singular useful? Oh, off by 1? Best of luck, thank you. Alright, I'm gonna see how the fast people did this because I've already done it correctly once, so. This is not a reverse iterator. Wait, what is this approach? JavaScript? What is wrong with people? Oh yeah, we just don't even need an iterator. Yeah, okay, sure. Triangle dot size -2 because we skipped the back one. Back is greater than, equal, 0, and back minus. Let's make this just I. Let's make this simpler. Should be I, or wait, no. Auto cur equals triangle at I. We want cur dot size. So dp at I. Dp at j. That's what we want. So we want cur j plus min of dp of j and j plus 1. Alright. Hopefully this is faster. This should be faster. Yeah, okay. Okay, we figured it out. that's enough of the LeetCode. Okay. So what I want to do today is actually, unironically, truly get fee insertion for mem to reg done correctly. Last time, if you remember where I left off, yeah, I was fighting through this function. You may notice there's a billion containers, and you may be wondering why. Yeah, after the stream, I also was wondering why. So I was like, okay, let's take a look at the LVM mem2reg implementation. I think it was in here, right? Or no, it was this. Yeah. So I look here. This is like the LVM source code, by the way. So I'm like, okay. Promote pass run. Okay, this is the literal pass. So then I look at this. This is just like boilerplate to make promote memory to register work with the pass manager. So I'm like, okay, so what's in promote memory to register? And it's this function over here. So I look at it a little closer, and I'm like, we iterate through we look through the entry node. We look through the entry node here. We iterate through it. And then we check it. We dynamic cast to see if it's an alloc. And then we gather all of the instructions that are allocs that are promotable. And then we have this promote mem to reg thing. So I'm like, where is this? Where did this go? Okay, we're really struggling to read this. Last night, basically, I read through this. If I remember correctly, I think this is just like this iterates per variable. I could be completely wrong, but okay, where does this live? The anonymous namespace. Oh wait, I might have been wrong last night actually. Holy fuck. Me when I spread misinformation. Oh wait a second. Is this all? Oh Christ, okay. Okay, I might have spread misinformation last night. Yeah, my fault. Yeah, so what I thought was happening was that it was just running per variable, but now that I look closer at this, it does just like, it just runs, it runs properly, so, or as in like, it runs, I think once per block, so, right? Or, yeah. Yeah, this just iterates once through the control flow graph, I think. Okay, so this is the work list. Delete assignment. Yeah, some sort of a mess. What happens here? Sure. Okay, I do need to read through this more closely, actually, it looks like. No uses, we just nuke it. Get the reads and writes. Single store, we just directly replace it. And this is per allocate. Okay. Wait, am I, wait. Wait, I might have not provided misinformation. 1 second. We calculate fee blocks. Yeah, okay, so I might not have provided misinformation. What does this even do? No, there's a work list. Oh, this is the rename. Okay. Okay, yeah. So it does insert fees per variable, which means I was not passing around misinformation. I just might have linked the wrong part in the docs, or the wrong part in the source code, but yeah. Bottom line, I was trying to do it so that we insert fees for every variable with just one pass across the control flow graph. It turns out what's happening here is it's iterating over once per variable, so yippee. But yeah, that means I can kind of at least justify to myself that I can just implement it in a way that runs once per variable. What's up, Janine? Sorry I didn't reply earlier. Okay, so let's get implementing, I guess. We can nuke a lot of this stuff since some of this doesn't really make sense anymore. I think we still need this. We should reorder this actually. So dominance frontiers, we still need this, that's fine. This should be a map from instruction allocate putter to unordered set of basic block putter. And this is defs. So then we need to fix this loop up a little bit. So we dynamic cast. What did I change? Oh, I see. So we dynamic cast each instruction, and then yeah, so we dynamic cast it to a store, and then if that exists, then we want to insert this block as a block where that variable is defined. So we want to change in this. We want store get putter, and then here we want to insert the basic block putter. So yeah, that should be good. We need to clean the hell up out of this, because we're not doing pair shit anymore. The rest of this, I think we can even just iterate per. Oh, we still need this, right? We can get rid of the layer of indirection here. We can just directly map from a basic block to a set of phi, I guess. Right? Or just the vector even. right? Yeah, okay, yeah, that makes sense. Because we want a separate visited list. So we want a vector of that. What's wrong? Okay. Yeah, so now we want each. Can we do like structured bindings for an ordered map? Or whatever the C++ is called. Base type, okay. Yeah, so we can iterate through like that. That's nice. That's good, Skittles. Good to see you. I'm trying to actually, unironically, truly correctly implement memtoreg now. I'm giving up on like the one basic block pass idea. I'm just doing once per variable and calling it a day for now. If this ends up like piss slow, then I'll rewrite it. But until then, I think this will surely suffice. Okay, so we have fees there. We want auto const. We want, what are we iterating through? Allocate and blocks in defs. We can put this down here. We want to make a work list here. So we want what type is this? Unordered set of basic block putter. Hope it's fast. Yeah, we'll see how fast this ends up being. Oh god. Okay, well I think this is the correct type now. So we want auto block here. Block ref. Okay, so we actually want to turn this set into a vector. Basic block putter. So we want blocks.begin, blocks.end. There we go. So for each basic block in the dominance frontier, we want a visited list. Or visited set. Okay. Do like this. And we want to change this up. Close to 1K, will probably be there in a couple days or less. Maybe if I don't show up late to my stream, because today I might have scheduled the stream for 7 o'clock local and then shown up like 7:20, but Yeah, so it goes. Yeah. I guess I'll plug my channel as well while I'm at it. If y'all haven't subbed yet, make sure you sub to the channel. It helps get my content out to more people. And we're also really close to 1K subs, which once I hit, I'm able to have enough subs for 2 tiers of monetization, but not have enough views for the first one either. So it'll be really funny if that happens. So please sub to my channel if you haven't. So we want visited here? Or no, we want blocks. Does 1K enable super chats? I think 1K enables mid rolls, or like just like general ad revenue. Whereas I think it was 350 enabled super chats and like more active forms of monetization. Yeah. I don't like how blocks is named here. We want... Actually, no. We can do def blocks. Do that. This is fine. So then, what do I even put into these fees? I genuinely don't know what to do here for this one. I have this up in my little write-up, I think. Add fee to it. Well, fuck. That doesn't that doesn't help me. Well, shit, okay. Okay. Or maybe I should reference the book, huh? Restello. SSA book. My favorite book. Okay, I don't actually know if it's my favorite book. That might be a little bit troll, but this book is very useful to me. View summary? No, fuck off. Okay, so do we like update fees later, or is this just the only fee instance? Okay. I guess we could just... What do we initialize it with? Let's just insert it for now. We can fill it up later. I'm gonna make unique MIR instruction fee. I don't think this takes anything, right? Oh, I am so wrong. We need the allocate, right? How is it? The allocate? Let's see. I have it. I literally have it in here. Okay, so there's just no constructor. What's wrong here? Okay. That doesn't help me. That really doesn't help me. I should just like make a default constructor, or like, oh, stood unique putter. Wait, no. Wait, what am I doing? What do you mean it's deleted? Oh, we need to give it a type, I think, huh? Yeah, okay. We need to add that real quick. So we want instruction fee. This takes in type. So let's steal this real quick. Okay, so all the terminators, so it has to be here. Okay. Here. Fill? No. Type. How do I call the super with type? Oh, value. Okay, so now we can give it wanna var type. We want type, I guess. I'm gonna get type there, and then we can stick that in here. I've been grinding quant dev interviews for the past 3 months and finally been offered a role. Keep up the grind, it will pay off. Thank you, and congrats to you. Can't wait to see compiler engineer streams. Hopefully that's the goal. We'll see what happens, but it might be a hot second until I get to that point. But even still, there's a lot of fun stuff ahead. It won't just be working on Panic, which is what I'm calling this compiler. I might do some like research work on stream as well, because there's a whole lot of stuff I want to get done. Also, like, for instance, like for our finals week, or like the week before our finals week, all of our like I guess ironically CS is like the one, like CS counts as engineering, so we don't have this, but all the non-engineering majors, they have this thing called reading week. So they just don't have classes for the week before finals week, and that's used as like study time. So I think it'd be really funny if my streams during reading week were literally just me reading, like reading through this book, or like reading through another paper or something like that. If that's something that y'all might find interesting, let me know in the chat. If that's something that you explicitly think will be the most boring thing ever, please let me know so I know not to do that. Yeah, just let me know what you think about it. We also had reading week when I was at uni? I see. This might just be a very ubiquitous thing across many different schools then, I suppose. It might be a little... Honestly, now that I think about it, it might be insane to not have a reading week. Okay, so we want... fees at... basic block. Get? No, we can just do basic block. We wanna... Oh my god, I can't type. I'm gonna move the fee back. Okay. Okay. Just to test this, does this compile first of all? Or does this build? Does this build and then does it run is the second question. Okay, make. Okay, so that at least runs. This still has stack pointers, which makes complete sense. That is what is supposed to happen. So then, let's try printing things. Pair in fees. As an engineer who didn't have any formal CS education, I like watching your stream when you're diving into details of algorithms. That's just one opinion. Okay, I'll keep that in mind. Yeah, I might do that for reading week. There's a very specific paper that I think would be interesting to read through. Let me find it real quick. It's somewhere in my little pirate box. or sorry, attained legally box. Yes, this one. Yeah, so I asked my PhD mentor if they had any recommendations for, I guess, like learning about what optimizations even exist, and they pointed me to this paper, which is from like, it's like 1980-ish, plus or minus 10 years, but it's pretty much just like a catalog of all the big optimizations that exist. So this might be fun to work through. Yes, like loop transforms are huge. There's like, even above this, there's some like procedure integration. Yeah, there's just a lot of stuff here. This would be interesting. But yeah, it's called A Catalog of Optimizing Transformations. If you want to look that up, I think the paper is open source, so yeah, you could give it a quick read or something. Yep. Yeah, I might look through that during reading week. Maybe like create some sort of like a taxonomy of like LLVM passes. That would be kind of fun. Yeah, that's all future thinking. For now, we got fee functions or fee instructions to print. So we want to make a toString visitor. We'll just do this. V visit. Alright, now we want pair second accept V. Or wait, at V? Where is this going wrong? Need to go back to compiler Blackmagic. Great resource, yeah. Happy to share that. What's wrong here? Oh, I need to what does this take again? I forgot. Function. Oh, most vexing parse. Okay. What was the constructor I had for this stupid thing? Okay, maybe we're not printing like this at least. Be at here first. Do we have, oh, we don't have IOStream here? Alright, hopefully this auto toStrings. If it doesn't, that'll be really funny. Okay, this only has one fee inserted. That's not ideal. Do I... What? We want work list dot size. Let's print some more information out. Size 3, size 1, and we only insert one fee. That's really strange. Have you profiled anything performance-wise? I haven't gotten to the point where I can even profile anything, to be honest, I think. In terms of like raw compiler speed, I don't think that matters too much, at least for me. In terms of like code quality, I can't really like run anything, so. I guess I have like rough profiling just from like, because the little gtest regression test runner I have written, it does a little bit of like, it has like timing implicit in it, so I can kind of just like look at the milliseconds everything takes and then kind of do a little bit of math to see what takes a year and a half and what doesn't take a year and a half, but it's relatively insignificant for the time being because the programs I'm feeding in are just so small. So yeah. Why is this only Oh, wait, am I tripping? Oh, yeah, okay. Wait a second. We should have 4 fees. Just trying to get all the parts? Yeah, that's pretty much where I'm at right now. Also because I low-key don't want to tackle the back end right now, so that's it's a little bit daunting. Even though I've like done it once, but it's still just like a little bit scary. So I'd rather push that back as much as I can. So we want. Let's just put the string here. I'm lazy. I can make. Okay, well, we insert once, which is really not ideal. Something seems very off. We should definitely be inserting more than once, I think. Right? Wait. Oh, wait, the program I give it is shit. No wonder. Okay. Okay, where does this test live? It lives in here because I gave it like a really piss stupid test, so we don't really insert many fees. It's this one. Okay, so we want this. So we can just do res equals res plus 1. We can just throw this everywhere, even. We can throw that there. Let's put it here. Let's put this. I pasted over. Whoops. This works, and then let's throw one here as well for good measure. Let's just make a complete mess out of this program. Yeah, hopefully this isn't like stupid. Okay, this should do way more. Yeah. Oh, wait. What the hell? Oh yeah, I guess the dominance frontier is differently sized. Yeah, dt.c is the source file for the program. And that's just like an example because I just need a program that has a bunch of, just a giant mess in it, I guess. Let me pull up the control flow graph that I drew for it. I have it somewhere saved. Okay. So we open this back up. Let's just paste over. Yeah. So where would the fee nodes end up here? We'd probably have one in this return block. We'd probably have one here. I guess that's all we would need. And then, wait. Yeah, it should be all we need. Yeah, because all of this is just one variable. So I don't see where else we could end up with a join. Unless I'm just completely reading this wrong. Okay, maybe I just like insert the fees for now. Let's just give that a try. And then these are vectors, right? So yeah, okay. for each pair in, I guess like each basic block and fee vec in fees, we want so we want get instructions, insert, we can just insert 0. We're just gonna make a mess out of this. Or insert range, ooh. Mem to reg stands for memory to register, yes. It is named that way also because LLVM has a pass that does that exact same thing. It converts stack variables into virtual registers. Copies of L. Jesus, that's awful. Okay, we might just have to iterate over feedback. We want bb.get instructions. This is gonna be like dummy slow, but is that what we're developing right now? Yes. The goal is kind of just like an LLVM clone. Stack to register, yeah, because so the IR I have built right now is static single assignment, or like it's in an SSA form or a static single assignment form. So each variable, variables cannot be redefined pretty much. Each definition of a variable is treated as a new variable, and that's useful because then we don't have to figure out like which definition is alive at any point. We can just like say, like, we can literally just point to the singular variable that defines a value at any given instant. But that makes construction and playing around with it a little bit annoying at times. So the solution is when I generate code, I just generate stack variables because those don't have to be SSA. And then my idea is the mem to reg pass will just turn them into SSA variables pretty much. Okay, C++ vector insert. That's what I'm looking for. We know position, so instructions, begin. And then move fee. This is for reference. Okay. Let's see if this builds. And then this should also print as well, which will be useful. Okay, yeah. These shouldn't be putter type, but oh, wait, yeah. Wait, they shouldn't be putter type. Wait a second. Okay, get alloc type. Yeah, we got 2 in the return block, it looks like. Yeah, we have 2 fees in the return block. Why do we have 2 in the return block? We don't need 2 in the return block. Something's wrong. The fuck? HIR. Yeah, this order should be correct, at least. Yeah, so we should have 1 here, but we have 2 here for some reason, which seems wrong. That means our visited list isn't working properly. Like, there's literally 1 variable. This doesn't make any sense. What are we inserting into visited actually? Is it just the current block or the dominance frontier block? Work list is just the, I guess, the queue for basic blocks that we access. Where the rest? I can't type. Ignore all of the Valorant stuff that shows up in my start menu. There is no Valorant in Ba Sing Se. Okay. We want to add Y. So Y is the basic block in the dominance frontier. It should be correct. Yeah, don't worry about it. Rewrite this part too? No, fuck off past me. Okay. So for each variable name, we make a work list. This just gets filled with the all of the defs of that current variable. And then we have a visited list. I don't think we need to print that anymore. We don't need to print that anymore either. Yeah, don't worry about the questions. It's good practice for me to at least think this through. The for loop at line 59, it's just iterating over each variable. So it's just like the equivalent to this first line here in the pseudocode. Because defs here we assemble a little bit above. Yeah, right here. So we just iterate through all the basic blocks in the function, and then we iterate through each of its instructions, and then if it has a store, then we add that block to the list. Or we add that to the list for the variable yeah, we add it to that variable's list of blocks that contain definitions. Apologies if I'm like explaining this in like a kind of convoluted way, but feel free to ask more questions if still confused. The purpose of tracking visited blocks is so the point is that we don't insert duplicate fees, but if you remember from here, something has gone wrong. Something has definitely gone wrong. And I don't know why something has gone wrong. Maybe I do a different program. Let's just do fee insert. Let's see. Let's just make something. Let's make another control flow graph, I guess. So we have an entry node for sure, and then we have a return node. That's giant. We can make this smaller. Okay. So we want if true, if false. We want to rejoin these that continue. Or actually, we could make this split even. Once again. True 2. False 2. These rejoin at cont 2. And then these two join at like if cont 1, or just cont, and then that goes to return. So logically we'd need a fee here. Need one here, we wouldn't need one at return actually. Yeah, those would be the only places we need it, in theory. So let's do that real quick. Let's just steal everything from here again. Because that one's a little bit complex for me to figure out what's happening. So this is fine. Get rid of that. We can do a little bit more code duplication. Okay, so that's the true branch. We need the else branch, which is very boring here. Maybe I give these like different numbers as well. Yeah, actually that might make more sense. Do that. Yeah, that'll hopefully simplify things a little bit. Need to change the makefile. Insertion. I think that's what I called it. Insert. Okay. So we have a fee here, and then we have a fee there, which I think lines up properly. So we're storing a 6. Why is there another putter? Oh, that's the return value. Oh, that's why there's 2 fees. Oh, wait, I forgot I did that. Okay, let me back up a second. The thing I forgot about was that when I generate code, I implicitly add an extra allocate to the entry block for the return value. And then whenever we call return, instead of just like making an instruction that's just returning the value, we literally store the return value into the return register, and then we branch to the return block. Yeah, so that explains the extra fee. So I think this is working, is what I'm getting from this, which is a very good sign. Yeah, we have a block here. We have one in both of those. They should be in the continuation, just to double check. So that should be one in the we assign 4 and then we assign 6. Yeah, so we assign 4, so that's one of them, and we assign 6. Okay, perfect. All right, this works. This does in fact work now. Let's commit some stuff. We changed the instruction. What did we do? What did we do again? Oh, add fee constructor. Oops. And then implement fee insertion in mem2reg. Okay. So that's one half. What version are you what version of C++ are you using? Are you using any 17, 20, or 23 features? I'm compiling with C++ 23, but I think the most recent feature I use is from 20. Let's check what compiler. It should be Clang. It might actually just end up being GCC or G++ though. I think I have a line. Yeah, I'm using 23. It looks like it's using the default, which I think would just be G++ here. I'm not using, so I'm on Windows, but I'm using WSL, so I get to use the sane person developer tools. In terms of features, I think I use a range somewhere. yeah, I use a range here. Just for a reverse view, but yeah. Yeah, I forgot I have this here. This traversal order shit's kind of ugly. Maybe I should like, maybe I should separate it out. Wait, this is so funny though. Why not just have native Linux? Valorant. There's no other reason. When do you plan to apply to compiler rules? Currently I'm searching for an internship for this upcoming summer because I graduate next fall. So I have another summer. So yeah, I've been like looking for compiler internships, but they're kind of hard to find. I have like a non-compiler internship still as like a backup, but I would rather avoid going back at least, if at all possible. But it's also like not the end of the world, I think. It just gives me more time to like keep cooking. Yeah, it'll be a good time. Forced to use database at work because security? Yeah, unlucky. Do you care about location? Honestly, not really. Just as long as it's not somewhere I'm gonna like get stabbed for walking outside, I think I'll be fine. IBM roles, yeah. I applied to 2 of the roles. I think one of them I already got rejected. Yeah. UK? I see. Yeah, that might not stand up to the whole not getting stabbed thing, but I mean, it's either get stabbed with a knife or like stay in the US and get shot by a gun. So like it's just kind of doomed either way. Yeah, all good, all good. Okay. What else do I need? I need to do variable renaming. This is the actually fun one. I low-key don't think I'm gonna reuse a lot of this old code, but I think I might use some of it, so I'll leave it around at least. Okay, so we want so we want to make a stack. We want to make stacks from, or a stack per variable at least. This might make a mess out of memory as well, but we'll see what happens. I'd only ever move here if you have a good salary so you can avoid the stabby part. Yeah, fair enough. Do you prefer C or C++ and why? Honestly, I don't really have a strong preference yet. I think they just like, they're written for different paradigms altogether, so it's like literally comparing apples to oranges. I have more experience in C++, so I definitely feel more comfortable with it, but I also appreciate like the raw simplicity of C, so yeah, I'm kind of indifferent between the two, to be honest. But if you held a gun to my head and made me pick one, I would pick C++ right now. How do I make this mapping without nuking memory? Okay, so we want... Well, a stack of reaching definitions. So we could push on, like, pairs, I guess? This is, like, yucky. You like object-oriented programming? It's familiar to me. I won't say that I enjoy it, but it's at least what I have the most experience with. Have you used any other languages extensively? A buttload of Python. There's a little bit of TypeScript here and there, a little bit of Rust here and there, a little bit of C here and there, but I think hours-wise, and in terms of just like lines of code, I think on my GitHub, I have like the little rating thing on my profile. Yeah. So it turns out C++ is now the most because I'm currently working on this slush pile. But for the longest time, Python was #1 here. And there's just inevitably a lot of TypeScript because like my personal website uses TypeScript, so yeah. Yeah, I think that's like the fast rundown. I wonder how much of the C++ stuff is also because I forked LLVM. I don't know. Anyway. I picked up Golang to develop web services. Yeah, that makes sense. Yeah, Go seems like a pretty elegant language. I just haven't had a reason to use it. Compiler rules use more functional programming or procedural than object-oriented. It kind of uses a little bit of everything, I think. It feels inaccurate to really like pin it to a singular paradigm. Like the OCaml compiler is like all OCaml, which is intrinsically functional. But also like the LLVM ecosystem is in C++, which lends itself to a little bit of object-oriented thinking at least. Yeah. Okay. Variable renaming. What am I doing here? Let's make a map. That inserts. No, it doesn't add anything. Okay. Let's make a map from instruction allocate footer, and then yeah, we want allocate footers, and then we want let's use a vector for a stack. A vector of pair, so we know how far up down to pop, I think. So we want a vector of pair of, or actually, no, we don't need a, we can do just vector of unordered map. So then this takes, we want allocate, and then we want value. Value is just like the generic, I guess, I hesitate to use L value here, but it's like, it's the value to the left side of the equal sign. It's not like an L value by definition, but like, yeah. And from embedded to CAD to finance, and there wasn't really one paradigm. Yeah, exactly. Yeah, I think some languages lend themselves to certain paradigms, but they aren't like intrinsically bound by it, I guess. LLVM is what again? I think, what does it stand for again? I think it's like low-level virtual machine. Yeah, it's pretty much the it's pretty much like a I guess like the compiler, the big compiler toolkit that's industry standard. This is where Clang comes from. There's some like other things you might see here, like MLIR if you've heard of it, LLD and LLDB, which is like their rewrites of GDB and LD. They also have their own CUDA compiler, which is not closed source, but also like NVIDIA's CUDA compiler is built off of LLVM. A lot of other projects also use LLVM for their backend and cogen, because the idea is that like I get to draw this fun diagram again. This is the best thing ever. So let's say you have M source languages and N backends. So if you have like say C here, we have C++, let's say like Rust as an example. And then we have like, just oversimplifying the backends a little bit, we have x86, and then we have like some form of ARM here, just as an example. So if we were to write like an individual compiler from each of these, we would have to write 2 for C, we'd have to write 2 for C++, and then we'd have to write 2 for Rust. So we would end up writing M times N compilers, and each time we would have to like re-implement all of the existing optimizations from scratch. We'd have to like implement like backend code gen from scratch. It's just a repetitive mess. So the core idea behind LLVM is that we had this unified middle-end language, which we're calling LLVM IR. And the idea here is instead of writing M times N compilers, we can just write M language front ends that lower from the source language to this IR. So we'd have 3 here. And then we can keep an existing optimizer at the IR level that we can reuse. And then after that, we can write n different backends that go from IR down to assembly. So instead of writing m times n compilers, we go from that to m plus n, which scales way better, and we can also reuse a lot of infrastructure. So yeah, that's like the rough explanation of why LLVM is really cool. We can also use make a bunch of other external tools. So like from here, this is where we get let's see. We get ClangD, for instance. It's like analyzers. We get we can create linters from this. So on and so forth. That's the rough idea. It's a way to get compilers to run on a VM to run on any architecture. I think VM is a little bit literal of a term. It's mostly just think of it as a high-level instruction, high-level assembly language, I guess. With the goal of reusing different parts of code. And then MLIR is somewhere way over here, or somewhere in the middle here. I don't remember exactly, but yeah. Laptop with Fedora and dual boot Linux Mint. Yeah, fair enough. League has to be played some way or another, I guess. I feel like C++ is harder to use than Python. I don't know. With Python, you just write in plain English what you want it to do, and it just works. Yeah, that is true. A lot of the Python libraries are C++. Funnily enough, some of them aren't, and my PhD mentor, he rewrote one of the I think it was Network X. He rewrote it in C++ just so we could do crazy compiler shit to it, and just the rewrite alone, I think sped it up 100x, which is really funny to think about. But yeah, I think the Python interpreter, I think, traditionally is programmed in C. It's traditionally programmed in C. I guess that's where C Python comes from, or Python. I forgot what it was called. Someone's working on a Rust interpreter as well. I've played around with PyTorch a little, but not too substantially. But yeah, its backpropagation is pretty good. One of my upcoming homework assignments, by the way, will just be implementing the PyTorch core from scratch, which is, it's gonna be a good time. Yeah, I'll report back once that's done. Going for a PhD? Not quite. So I'm going for a master's right now, but my advisor is a PhD candidate. So that's what I mean when I say PhD advisor, I guess. It's shorter than PhD candidate advisor, I guess. Okay, where was I here? Let me turn on the AC. I'm melting. Okay. We want a mapping here. Yeah, so this is cur defs, I guess. Masters is on correlation and attention AI, so use PyTorch. I see. Yeah, PyTorch is quite neat. I almost want to do more ML stuff. I just haven't had a reason to, at least. Yeah, the Python is kind of just it's kind of just fake looking. Yeah, the theory is it's really fun just implementing theoretical algorithms, at least. I've been having a blast just trying to implement all of these SSA construction algorithms this whole time. 3.3, this is the one we want. Do you know Tencent? Yes. I mean, I'm Chinese, come on. What the heck? Okay. Format. So cur defs is fine. Reaching defs. We're gonna just call it reaching. Reaching? Yeah, okay, this makes sense. What's an SSA algorithm? SSA is short for static single assignment. It's the code property that each variable is only defined once. Or I guess like a definition is treated as a separate variable, and that helps make code analyses a lot easier. But it's really annoying to like go between an SSA form and like a non-SSA form. So the algorithms to create SSA form are SSA construction, and then the algorithms to I guess go from that form back to just like variables with reassignment is SSA destruction. Tencent has their own ML framework? Ooh. Yeah, that seems... That sounds about as I would expect. That just sounds like the standard C++ experience. But it's really cool that DeepSeek was written off of that. DeepSeek is just like kind of crazy to me the more I think about it. I don't know. Okay, so we have reaching defs. We want to do this depth first preorder traversal. We might need to we might need to make a little bit of a helper somewhere. I have like I have a post order traversal here. Yeah, let's steal this at least. Do you only speak English? I speak a little bit of Chinese. I can't really write it, but I'm at least kind of able to speak. Like if someone was like talking to me, I'd probably get 80% of it, I think. Yeah, that's kind of just the growing up as in a Chinese household experience. Mainland. Game programming? Actually, a little bit, yes. When I was first learning how to code, it was in a game dev context because as a child I was quite addicted. And it was pretty fun, but I wouldn't say any of it has been like very substantial. And I definitely know more about it now, especially since I'm like taking a game dev class, which is... It's not necessarily in my interest field, but it's still really cool to learn about, at least. Yeah, so I've been learning about that. Yeah, it's all a good time. So we want... How do I get the traversal order here? So we want vector of basic block. So we want... What did I call it in here? Recurse post or number post order. We can just do. We can make a function just called preorder traversal. Yeah. Let's. Where was I? I was in here. So we want function. F? Reference, I guess. Start learning Mandarin. Yeah, it's a whole lot. There's a lot to learn. I think your message might have gotten nuked by YouTube's just chat filter, so feel free to like ping me in the Discord or something. Okay, so we want vector. We can just steal this. Res. F get entry block. We need a helper here, actually. So we want void reorder recurse. So we want basic block header. Cur. And then we wanna throw this line in. Do this, and then we wanna push back. Oh, we also need a visitor list for this, actually. This should be passed in by reference, and then set, and this is visited. So we push back. Just joined the Discord. Good stuff. Yeah, my master's is in computer science. Yeah, I'm mostly just focusing on, if it wasn't obvious, I'm mostly focusing on compilers. So we don't have like a specific subfield for that per se, but like, or like a concentration or anything. The closest thing would be systems, but I think it's like formally in the systems area at least. What theme do you use for NeoVim? I use a slightly modified version of Tokyo Night. It's in my dot files. It's public on my GitHub somewhere. What am I doing? Oh, right. We want to add cur, and then visited push back cur, or insert. We want cur, get successors. So if this has successor, then we continue. Otherwise, we want preorder, recurse, we pass in successor, res, and then visited. Okay. So we do this, we have cur, and then we want oh, wait, I can do this with a stack. I just realized. Okay, let's do this with a stack instead. Let's nuke that real quick. I also learned Chinese by just listening and speaking. Yeah, it's so difficult to write, at least. There's just so much to remember. Also reading is like low-key kind of difficult. English and Spanish, those are good languages to know. My girlfriend is Chinese yet, so she helps me a lot. I see. Yeah, I think the hardest part about learning any language is just like finding opportunities to use it, or like opportunities to get like active practice. So it's good that you at least have somewhere or some way to practice in a more everyday context. Oh, it just occurred to me I have another traversal that's like recursive and not iterative. Yeah, this is gross. I'm gonna rewrite this to be iterative at some point. Recursion is my enemy. Like I had to write a recursive thing for a tutorial like a couple days ago, and I like almost forgot how to do recursion. It was pretty funny. Okay, so we want cur is work list pop back. Oh wait, no. We want back, and then we want to pop back. That's not visited. We want we want a set of basic block visited. This makes sense. We pop back, and then res. We want to push back that. Yeah, I want to push back cur, and then visited. We want to insert, and then we want cur get successors. We want if it exists, we skip it, and then work list. We want to push back cur or suck successor. Okay, I think this is the correct. I think this is the correct way to do DFS iteratively. It's been a hot second since I've written this. Yeah, recursion definitely looks elegant, but it low-key just eats through the stack like I ate through my dinner earlier today. Yeah, not a good time. You know OCaml? I've heard of it. I haven't written any OCaml code. Yeah, I haven't had the chance to, at least. Man with just docs and ID in 2025. That might be a little bit of a hard sell. I use a little bit of ChatGPT here and there when I get like super stuck, but I don't use like GitHub Copilot, at least. Yeah, it just doesn't feel like a great workflow for me, and it also low-key just does all the fun stuff for me, so like why would I use it? Okay, so we have pre-order traversal. I might want to just like throw these traversals into like I might just like yeah, I might throw these into like a separate traversals.cpp somewhere. Okay, so we have pre-order traversal, and then yeah, I guess the details wrong. That is like probably the worst part of it even. Although it is like very validating to know that like when I make a mistake, it's a very common mistake to make, so it feels like just a little bit better, you know. Pre-order traversal. What is this recurse? Oh, I see. I know what that is. Why is that there? Oh, I know why that's there. Recurse. Oh yeah, I was trying to copy that. Anyway, we're gonna get rid of that. Final basic block modification. Yeah, there we go. I was gonna have to write repetitive blocks, or use it to cut out manual parts of writing code. Yeah, that's fair enough. It's really good for like boilerplate and like things that you would want an intern to do, I guess. I think that's like the easiest way to think about it. So we want each basic block in pre-order traversal. We have this nice little function now. Okay. So we have this now, which is really nice. Oh, wait, we can't like pop blocks anymore. We need numbers as well. Hash map with 100 manual keys, youch. Yeah, that's like a perfect use case for GPT. Also I need numbers, I think. How did I do it in, how do I do like this thing here? Okay, this recursion thing is actually irritating me a lot. Okay, we're gonna make a traversal order thing as well. I think we need numbers at least. Yeah, we need numbers. We need numbers. We need numbers. Because we need to know when to backtrack. Yeah, okay. Wait, no, that wouldn't work. Wait, what am I doing? Yeah, I would like to avoid recursion if possible, but I also feel like there's no clean way to like know when to pop from a stack at least, I think. Yeah, we just have to like keep numbers going, I guess, which really sucks, but it is what it is. How do you decide what to build? I can decide where to go after building a toy language, so now work on issues in LLVM, but I want to create a proper language. Well, for me, I figured I want to kind of like recreate the infrastructure that LLVM has, so that's why I'm like building a compiler from scratch at least. I'm not sure if that like answers your question at all, but it's pretty much just like whatever you want. Like it's a pretty poor answer, but that's the best I got, unfortunately. Okay. How do I do this? Like, actually, how do I do this? Because the number will always go up. So, what's your problem solving tech? Yeah. I'm trying to figure out how I can keep like stacks of reaching definition going, in a reasonable way here. Because my idea is I just have like a stack at each basic block, and then like, yeah. But I feel like this doesn't quite do what I wanted to. Okay, new plan. We're not gonna do this like, what the hell? Okay. Where am I? Yeah, we can steal all the stuff in here. And then, or 13. We can steal this, And then we can paste over this, at least. And then we can get rid of this period traversal function, because honestly that's not really useful. This way we can also keep track of the stack at each point. So yeah, that'll help a lot. So this is where we visit, I think. Do you think it's worth building a toy language for learning reasons, or more efficient to just read a paper? If you want to understand the theory, I think reading a paper is largely sufficient. But I think like it's really hard to internalize without like doing a lot of the legwork yourself. Like I had like a rough idea of like what the SSA construction algorithm did, but I don't think like if I hadn't done like what I'm literally doing right now, I don't think I would understand it as well as I do right now. And like even still, I guess like I'm like slowly understanding it more and more each stream. So take that anecdotally as you will. Okay, so we do this. Work list we should do a vector of pair of, so we have basic block putter and then unordered map. Yeah, this might make a little bit of a mess, but it'll be fine. Yeah. So we want the reaching definitions map at each. So I guess we yeah, we kind of just have to like bite the bullet here. Yeah, this thing won't work. So we want to map from we want allocate putter to value putter. So we want entry block and then empty. What's wrong here? Oh. One more of those. Okay, we fixed that. That's a little bit of a mess, but so it goes. Yeah, okay, so we want depth first, period traversal, so we can do it like this. We keep hopping from the back. Also, like, one this is gonna sound really silly, but it took me like 2 or 3 years to realize that like an iterative approach with a queue is BFS, but an iterative approach with a stack is DFS. Like, it seems really simple, but when you lay it out, but it's like you think about it and you're like, damn, that's pretty cool. I don't know. Data structures is funny. So yeah, little funny insight. Okay, so we want to insert cur and then okay, so we want cur block, nice like BB, and then basic block, and then we want reaching. I guess we can do that. Can I like just move it? or no, this doesn't work. So we want this on back. We can't do it like this pretty like Python structured bindingsy way here, unfortunately. So we want first for the basic block, and then it's not reaching to equals the move of work list dot back. And then we can pop back. Yeah, okay. Yeah, and then we can just update it each time. And just pray that this map doesn't grow too big. If we hit a point where it gets too big, then like, tough shit. I'll clean it up, but yeah. So we want to insert cur, and then we want to insert reaching. Or we want... Wait, the visitor is just a basic block, so we can just insert basic block. So we want to push back. The applet, yeah, I stole that from somewhere else. If you click it, I think it links to where I stole it from. So, yeah, you should show them some support because they did all of the legwork. So we want to in place back. So we want successor, and then we want work list. Okay, we can't do that. Push back. I can do it like this, I guess. What is work list again? Work list, we have... I always find interesting watching people coding low level until I try to do it. Yeah, I kind of feel that. But also it's kind of, I feel like there's a certain joy in just like working through the, just the nitty gritty and the, just like the, all the misery that comes with, I guess dealing with this sort of stuff. Just a whole lot of learning. And I think the learning is what I find most rewarding in computer science, at least. So that's my take on it, at least. What's wrong here? Work list is a vector of pair of basic block putter. Yeah, this is a basic block putter. And we need a map from allocate to value putter. Yeah, this should be fine. Do I need to make pair? I really hope this is not what I need to do. Have we found that when you learn how computers work on a really low level that the magic disappears and wish you never knew? Low-key, I feel like demystifying it is the fun part for me. So I don't think that really has happened to me, at least. Why doesn't this work? Let's look this up. see. Okay, we might have to do the little... We can't do the structured bindings thing, I think. Oh, wait a second. Can I do this? Oh, wait. Like this? That? And then... Why doesn't this work now? Oh, reaching. Okay, there we go. We figured it out. Yeah, okay. Yeah, preemptive scheduling it, or just like scheduling in general is like kind of crazy. I'm taking OS right now, so I'll report back to you when like I get through more of it, but yeah, it's all pretty crazy work. It's all really cool. Even just like thinking about how concurrency works, and how it's all like fake parallelism is just like, it's just like, whoa. Okay, so we can do that. And then we need to actually visit now. So for each instruction in get instructions. Okay. Oh, we also need to process the fees as well. We can do that real quick even. So we want fees at basic block. Okay, that's a good start. So I wanna update reaching. We're gonna create new variable. And then, oh god. Oh yeah, that makes a mess. Okay. Okay. Do I like associate the fees with actual instructions or like... What do I do for fee definitions again? Basic block, and this is just a straight vector. Okay, well that's not helpful. We could do a vector of pair even. These type signatures just get even longer. It just keeps getting longer. Just keeps going. What's wrong here? Oh, we need to make a pair. So we want... The hell do we want here? Allocate. Not allocate. What do we want? Allocate.get? Is that it? No. Oh, it needs to be a putter. Whoops. Okay, there we go. each process had its own thread? Yeah, that's a little bit ambitious here. I think, if I remember correctly, I think browser tabs used to each get their own thread, I think. And then like people realize like maybe it's a little bit strange that like YouTube can access the same memory that like your bank account website has, and it's like so yeah, now they do a little bit more. They stick them in their own boxes now, in some capacity. But yeah, it was a jolly good time when that used to happen. Jolly good time when that used to work. Okay, so now we keep track of things properly. I'll fix this later. Actually, let's just get rid of this for now. So we want to iterate over the fees, then we want to so we want allocate fee and fees. We want reaching at the allocate. We want to set that to fee, I believe. Oh god. Map type from incompatible type. Do I want .get? Okay, that works. Okay, we're making quite a mess here, but this is fine. This is kind of expected. And then we can reuse a lot of the stuff from down here, actually. Yeah, let's steal down to here. Alright, let's uncomment that. Okay, that makes a mess, but that's expected. Oh yeah, we need, I forgot, this needs to be Jesus Christ. Let's uncomment that, reformat. Yeah, a lot of things are broken, but this is expected. Let's do that. Let's get rid of one of these braces. Don't need to deal with fees there. Yeah, we need indices because we need to figure out which ones to remove, at least. Yeah, so we want to remove. Actually, we should make a mapping as well for that, actually. So we want wait, okay, what am I doing? Unordered map from basic block putter to vector of that. Oh, we can just do int here, actually. No, int is size, whatever the size type is. We can do that. need to change this. Actually, we don't even need this. So we want pp get. All right, now we should keep instructions. That. Why is my LSP just asleep now? Oh, there's a lot of stuff broken, that's why. We should not be going over allocates right now, to be honest, I think. Right? We should already have all the allocates. Right? No, I have all the stores. Okay, so we need to delete the allocates here. So we want to, okay, delete if promotable. Or let's just delete. Actually, no, we should just skip them. In theory, we already have deleted the allocates. You know, we'll leave this here for now. I think we need to just literally delete for now. We can do that. And then we can add to the list. So we want to indices to remove at basic block and the pushback I or end. Yeah, okay. Next, we want to handle stores. Yeah, this seems accurate enough. So this is fine. Can do that. We also want to overwrite on reaching. So reaching at store get putter. Yeah, so this is a write. So then I'll set this to store and get value, I think. Yeah, okay. And then finally, we want to I'm gonna do this god-awful thing. we have replace use visitor, which is so funny to me. Yeah, so we wanna replace the uses. We don't have curve val anymore, but we have reaching at get butter. Right? Yeah, we want that. And then this is so funny to me. And then we can add this instruction, and then life is good. Okay. So we want replace uses with reaching def, delete. Do that. Yeah, this is fine. I think this should be it, actually. We just need to do the final pass now, I think. Okay, I'm actually kind of excited here. We're really close to done. So we want to iterate across fees, and we want to add everything in fees, and we want to delete everything in indices to remove. So each basic block in F get basic blocks, I guess. So we want. What type is this? Unique putter to basic block. So we want. Oh wait, this is gonna be like giga expensive. I just realized. We're also gonna like nuke the hell out of. We're just gonna like fragment the hell out of the memory. Okay, this is fine. So we want a vector of unique putter to mir instruction new body, then if fees that contains, so if it has the basic block, then new body is stood move fees, I guess. At basic block. Oh wait, no, we can't do this. What's the pairing in here again? Allocate and feed. We can just steal this even. And then we go down here. Okay, so we want to move. We want to move the fee back. Oh, what's wrong here? Oh, we want get. Okay, so then we could do this little This is gonna be so funny. It's gonna be like really slow as well, but there's not really a way around it because we have to like make a copy anyway when just inserting the fees to the front. So this is the best case of the worst case. Time complexity, I guess. Yeah. Okay. So we want size t. So we want it to be less than maybe I should pre-allocate them. Yeah, we could. I don't think it matters that much, but it might be worth it. Let's get so we want to insert, so we want fees at bb.get, and then so we want to delete, so we want indices to remove, and do that. Let's rename actually. Okay, we substitute that at bb.get. So you have new body. I should pre-allocate this to so we also want instructions. So we want bb get instructions. So we want this to be instructions dot size plus to insert dot size minus to erase dot size. So we can pre-allocate that. Oh wait, no, this is wrong. We can do that, and then we want new body dot reserve. Okay, and then so we can do that, and then what type is to erase again? This is a vector. I almost want to iterate through this in reverse actually. Yeah, that might be... Nah. What's the best way to do this? Because we just have a straight vector here. Yeah, we can just like... Maybe I should use the bit set. I don't know. Yeah, we can just... So we want to erase, and we're just gonna be ugly with it. I'll clean it up eventually. So if that, then, or if it's not that, then we can just new body, wanna push back, gonna move we want instructions at in okay. Did it change? Oh, I see. So that we can just, or we can even do a continue here, and then do erase and plus plus. After all this, then instructions is now new body. Okay, let's give this a try now. I feel like this is gonna segfault, but we'll find out very quickly if it segfaults. Okay, so it's segfaults, which, yeah. Will this segfault? That will segfault. Does it work up to this? Okay, that works. Okay. Real quick, just as a sanity check, let's just print this size at each. Huh. That's not supposed to happen. Or wait, let's put it up here. Wait, what? Size 4? Oh, 4. 2, 1, 1, 1, 1. So we have 1, 2, 3, 4, 5, 6, 7, 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8 blocks. Okay. What's going wrong? Should work, surely. Unless I completely bungled something. Yeah, okay. Can I just swap with this even? Okay, that's still side faulting. I'm not really sure what the fastest way to do this is, to be honest. Wanna stood move this? What type is this? This is a stood vector unique. Okay, yeah, that's correct. Is there a way to do this? Oh, we can literally just... Wait, why doesn't swap work then? So we want... This should work. Oh wait, we should keep that a reference. And then... So I'm gonna swap with new body. Okay, so this is not what's supposed to happen. Why are these like that sized? Can I like, hello? Okay. Okay, so that's what's supposed to. That's correct. Yeah, I mean, I guess there's supposed to be less instructions, so that makes sense. Which one's the really long one? Okay, so 4-1 should be, yeah, this should be like nuked to hell. This is just a 0 now, I think. Yeah, a lot of this becomes really sparse, I think, so this seems about right. Yeah, it should be fine. What's going on with the 2-string? At least. Okay, let's see if this is a valid access. Wait. What? Oh. Yeah, I mean, this seems about right. These instruction counts seem consistent to me. Something's wrong. Why ain't this working? Real quick, let's just do a quick sanity check. Also, we can delete all of this, by the way. Yeah, that'll clean this up a little bit. Oh, I need to link up the feeds as well. I just realized I forgot to do that. Yeah, I'll do that after. For now, I want to at least get this printing. Oh, that might be why it's not. Oh, wait, it just occurred to me. Wait a second. If we have an empty fee, that might break something. Fee. Wait, no, this should work. We've printed empty fees before. That doesn't make sense then. Okay, let's make val grind. Oh Christ, okay. Get type? What? That's where it's crashing? Wait, that's... of all places, that's where it crashes. I'm just gonna throw this into ChatGPT. Oh, I see. Wait. Wait, what? Am I forgetting to add things to the... Wait, what? Oh, wait, it just occurred to me. Wait. When I find the load earlier. Is there an edge case that I'm forgetting about? Call doesn't take a value. Oh, wait. Wait, does it? No, it doesn't take a value. Yeah, we're using ChatGPT here. I might need to step through this with a debugger, which scares me because I have not used a debugger in forever. But I'm gonna try and avoid that as long as possible because I'm quite lazy right now. Let's do if small. Huh, that still crashes. Where is this failing? Value, toString visitor, value to type string. Where is this coming from? A store? What the fuck? We're visiting a store? We don't have stores anymore though. What? Us? Starting size 40. What the? Why are we getting rid of the allocate at the start there? Right? Oh, wait. Didn't make properly. Okay. Oh, we're not erasing properly. Okay, maybe we need to iterate through it backwards then. What? The fuck? Oh. Do that, and then pop back. The fuck? Oh, wait a second. Okay, wait, this doesn't work, I just realized. We kind of have to go front to back, I think. Oh, wait. We can do like an else here even. Stood out of range. What? Wait, what the fuck? Illegal instruction? What? When has that ever happened? What the fuck? What? Oh, wait a second. the fuck did I change? What? Wait, this has never happened before. Okay, so this works. This is fine. And then... I'm so... This should be fine. We want pass, we want cure. What the fuck? Oh, wait. Why is that an illegal instruction? Oh, is this just undefined? Wait, what the fuck is happening? Why is the sec faulting now? Okay, so if I just get rid of this, what happens? The fuck? Wait, I'm so confused. What the fuck is happening? What did I change? Dominator tree? Yeah, I got rid of IO stream. What? Wait, what? Wait, what is happening? I actually don't get this at all. What the fuck? What the... Okay, let's just get rid of all of this stuff first. What the fuck is this illegal instruction shit? What the hell? What? Yo, I've never seen this before. Like, literally ever. I've never seen this. Where is the legal instruction? Get type? What? Okay, wait. It's probably in here? Oh, yeah, value to type string. What? What the fuck? Wait, so something is segfaulting somewhere just earlier even. What the fuck? This makes zero fucking sense. Why is it not deterministic? What the fuck? I'm so confused. I have no idea why this is breaking. What the fuck? Any of y'all got any clue? What could possibly be causing this to brick? Do test build here? Okay, well I'm treasure base, but that's expected. Let's do call chain again. Yeah, so that works. So this works. Yeah, Yeah, this does exactly what it's supposed to. The fuck? Okay, and the test passed now, so like, what? Okay, I think this, okay, so this has to be something to do with the fee, I think. Let's give it a DT again. Is there a use that I'm forgetting about somewhere? What could I possibly be messing up? Maybe the way I make the fees? What if I delete that? That didn't change anything. Singles last time? Yep. I'm trying to get Memtorch to work. I have most of it made now. There's just like some small bug somewhere that I'm trying to figure out what's going wrong with. Let's see. That's a reference, so this should be fine. Maybe... what kinds of compiler rules are there? There's plenty. Like for instance, like Apple's Swift compiler, NVIDIA's CUDA compiler. There's just a whole lot of stuff out there. Even like TensorTorrent for like their proprietary stuff. A lot of the rules are either like contributing to existing open source things, or it's like working on new stuff for new hardware. What are your ideas for backend? Like the compiler backend, or like backend stuff in general? Because compiler backend, I have like a nice screenshot somewhere in my Discord. Let me pull it real quick. I'm getting pinged everywhere though. 1 second. Clear some of these in a second. Where does this live? Compilers? Yeah, okay. Yeah, here. This is a screenshot. All the green stuff is stuff I have to do still. I'm working on control flow right now. I did this rewrite thing, or smart pointers rewrite already. Yeah, this is like the pile for backend. I want to, just like the standard instruction selection, register allocation, and like code gen with people optimization here and there. Yeah, that's like the short, fast version. I don't think it's particularly interesting. Okay. Graph coloring? Yeah, that's my plan for now. It's the one I'm most familiar with, at least. I might play around with different algorithms at least. We'll have to see how things end up going. How are online code errors made? I'm gonna be honest, I'm not that knowledgeable about that, at least. You'd have to ask someone else, unfortunately. Let's see, how can we print better? We want two-string. Let's do IO stream. What? Wait, what? Seems crazy I can compile C in a web browser. Yeah, it is quite nuts. I wouldn't be surprised if there's like a service in the backend that just handles that. What is wrong here? Oh, this is in the wrong place. How could we possibly be failing there, of all places? Like, what? Okay, what the fuck? Oh, you fucking know what? I think I know what's happening. I think we're not resetting things properly here. Between passes. So this is in pass, mem to reg. I'm also running this per function? No, this should be fine. It's just across the entire program. What's going wrong here? This is fine. I forgot where this comes from. C assert, sure, fair enough. Yeah, let's just stick asserts in here, I guess. is I think something's not being cleared properly, even though it should be being cleared properly. I don't know how it's physically possible for this to be so broken. Where did you learn TypeScript? I kind of just learned it on my own. Not really formally anywhere, at least. What the fuck? Okay, this... I think my code is starting to act up a little bit. Where'd you learn how compilers work? I took a compilers class a couple years ago now. That's where a lot of my knowledge comes from, at least. Why is this? Okay, so this definitely has multiple basic blocks. Why is this quitting on one of them? Oh, I know. There's a use I'm forgetting about, I think, right? No, we get conned. Conned is, yeah, okay, we do that. Do I need to visit the... fucking hell. I think I'm constructing it wrong. I think that's what's happening. Let me just put this. There's a place where I assign uses, I think, right? Where is this? Declaration? Okay, it has to be here. Right. I think I keep track of uses somewhere. I hope I do. It's under value, right? Yeah. Where the fuck? Did I just never set this anywhere? Oh wait, no, we do a little bit here in the constructors. Wait, I think I'm forgetting to add one somewhere. Store fee, we're fine. return has a use. Const branch. Oh, wait a second. Wait. This is what I'm missing. This get use. Wait. Right, no. It's const get uses. Push back this. I think. Arrow? Or no? And this should finally work, right? Okay, it works, sort of. Yeah, we don't connect the fees yet, but we're really, really close. That was what was breaking. I forgot to add this to the constructor. I'm a little bit of a oops. Okay, so let's use a different one. Let's use fee insert. Okay. Okay, let's add add missing use add to const branch terminator. Okay, so that's that one. We can go back to here now, happily ever after. Get rid of the last prints. I don't remember where I put them. I think MIR. Yeah, okay. All right, now we need to link variables now, I think. How do we do this? Okay, how do we store these in the fee at least, first of all? So we map basic block to value. So we can just literally update it, I guess, as we go. Yeah, okay. So we can go back to mem to reg. Okay. Yeah, I guess we could update it in the store, I guess? So we can just iterate through basic blocks in we want basic block for successor in basic block, get successors. This we want fees at successor. So if this has a what's the allocate again? We have store get putter, then fees at successor. Successor fees equals fees at successor, and then we can change this to suck fees, which is really funny. It should be reference. Are you kidding me? I didn't realize I need to update this, so we're gonna need to re-architect this once again. Yeah, okay. We can do that. This is just gonna be permanently ugly, but that's okay. Go there, and then we need to we can do that now, and then we just change this. This is what we were working on before. Does this change anything at all? It doesn't look like it does. Okay, so you want so if it has this, then we want at we want get predecessors. Oh, this is gonna be such a fucking train car. But yeah, this is terrible. So at the predecessor, so we want from basic block to equal store get value. Jesus Christ, that's terrible. So we want and then we want we can declutter this a little bit. This needs allocate, then allocate. This needs to be value. Let's see if this builds now. All right, it looks like it works. Yeah, this control flow graph's a little bit funny as well. Something seems a little bit wrong here though. We're not printing the basic block properly. Let's just double check how LVM base feed. Let's see what the instruction looks like. So the first one is the value. And then these are the block it comes from. So this should just be a okay, let's add this real quick. Implement mem2reg. Holy shit, we actually did it. Okay, one final change I want to make before I end the day. I want to change a type real quick somewhere. Or I want to change the print rather for the fee because I think it looks a little ugly. Yeah, there's no other reason here. Yeah, so we want percent and then plus that. There we go. Okay, much better. And if we compare, it looks roughly the same. So yeah, we're up. Just out of curiosity, let's do like the big if test because I think that's the interesting one. That's not supposed to happen. Okay. Where could this be breaking? Okay, let's zoom in on this. Let's just comment all of it out first. Okay, that doesn't seem right. Okay, well we'll fix that one later, but that's not the one that's causing the crash at least. Okay, this is fine. Okay, we found the one. Found the culprit. No braces if else, of course. Everyone's favorite one. The infamous. let's copy this. We want if special. Real quick, make test. Okay, it still passes all tests, that's great. So why does this break? Let's go to driver real quick. That line break was annoying. Okay, so we're not even getting here. Okay, so we're dying in the mem to reg pass. Real quick, let me just like fix this shit. Okay, mem to reg. Pro debugging, yeah. Anything but use a debugger, you know. Yeah, I'll have to learn how to use one at some point. But until that day, I will avoid it as much as humanly possible. Okay. Immediately finding line number cycle? Yeah. I mean, to be fair, that is really helpful though. Oh, it's up here? The fuck? Why is it here? Compute dominance frontiers is failing. Okay, so it is definitely in here. Oh, wait a second. Wait, what? No, this should be fine, right? Oh, you fucking know what? Let's kill passes. Let's rebuild. What happens in this? Yeah, this should be fine. Let's just go straight line. Yeah, this should be alright. How do we even get to if cont? The hell? Oh, wait a second. Is this what I need to do? Oh, I need to enable that. No, it's still broken. 2 2 2 2 2. One, two, 3, 4, 5. This is the one it's breaking on? What? Oh, wait, I didn't account for this actually. Yeah, I see what's happening actually. I know exactly what's going wrong now. Yeah, the only place we call at is in Dominator tree. I'm getting lost in my files. It's in here. At. Yeah, okay. This is this one. I'm gonna use bracket operator here because I don't think it really matters if we just stick a null pointer in after the fact. The rest of these I think is fair enough. Oh wait, no, actually, yeah, these should all be. Yeah, these should all be that. Yeah, there we go. Okay. It's 1, 2, 3. Wait a second. 0. I guess we literally can't get to 5. So I guess, no, but we can. Wait, what the fuck? Oh wait, we can't get to 4, wait. Yeah, okay, this is fine. We can just dead code eliminate this actually, which is really funny. 6 can get through these. can't get to 5. Can't get to 4. Yeah, this... Okay. And then this one, this little mess of a function, we can't get to 2, so this is fine. Yeah, we could do a quick little dead code elimination as well, but yeah. I think this is a good place to call it at least. I might just throw in another to-do somewhere here real quick. We can just like bracket operator. Or actually, yeah, we can just do this for now. Or maybe we could even just like, a quick little, nah, this is fine. So we now can handle orphan blocks. Okay. Let's pull up one more quick test. I'm curious about. I think we never ended up testing fee insert, so I'm gonna test that real quick. Fee insert. Okay. Yeah. Okay. This looks quite nice. But yeah, I think I'm gonna call it here. This was a really productive stream. I'm actually quite surprised I managed to do all of mem to reg. Although holy fuck, it's been almost 3. It's like 3.5 hours now. Yeah. Thank you all so much for showing up here. Especially if you stayed this whole time. I'm not sure if any of you are still in the chat, but if you are, then massive shout out to you. Y'all are the real ones. Y'all keep me going. If you're still here after just a part of it, y'all are also goated, and yeah, I really appreciate all of y'all's support. We're really close to 1,000 subs. If I could hit that before October, that would be incredible. But if not, then like no worries. Make sure you like the stream and sub to my channel. It really helps get my content pushed out to more people, and it helps out a lot with the algorithm. And while you're down there, make sure you join the Discord. That is the first place I will post if my schedule changes. I made an announcement that I pushed today's stream back 30 minutes because I was hungry. And it's also the best place to just get pinged when I do go live and chat with other people in the community. And yeah, make sure you connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. So yeah, I'm gonna go chill now. I've written so much code today. Yeah, take care y'all, take it easy, and have a wonderful rest of your evening or day wherever you are.